Hi, everyone. I hope that you are all set up. I'm right now on stage. I'm just trying to figure out how everything works. I just want to make sure that everything is okay. Okay, so I hope you can hear me and see my slides. Okay, so welcome everyone to our first quantum communication and cybersecurity workshop. I'm going to go a little bit over the agenda just to make sure that you know what we are going to do. So the first part of this event is going to be some short talks by different companies. I'm going to start giving an overview of QURECA and that you understand why you have been invited to this and what we are doing at QURECA. Then Sonali is going to present Craft Prospect, and Sunisha is going to present Isara. Alexei will go with Qrate, and unfortunately, we think that Konstantin cannot make it to present QSecure, but we are sure that next time this will be possible. At the end of my talk, I'm going to give a little bit more instructions of what we are going to do on the next session, which are these roundtable discussions. And I will give also a little bit more rules of how this speed networking works that I hope that you will all enjoy. So let's start with QURECA and how all this started. Most of you know me already. So first of all, thanks for joining us today. I really wanted to bring this all discussions up following the webinars and when I was talking to you. So I hope that you can get the most of this event today. So as you probably know, QURECA was born when I moved from industry into academia, and people started to talk about quantum technologies as a business. And there was, I found that there was this big gap between the mindset in academia and the mindset in industry. And everybody knows that. It's really everywhere. And everybody knows that it's really hard to develop something from fundamental science into an industry, into a market, into a business. But also, if you think here, we have the general public. There is a kind of a weirdness and excitement associated with quantum. People like to hear quantum. There is even quantum toilet paper now. So you know that this is something that people call it. There is a hype. We know that it's there, but we need to make sure that what we do makes sense, that people understand what we are doing in this new quantum technologies market. And also the government, they are at the end putting all this public funding, and we should be sure that they understand why this new technology is going to be so important. So that was really the reason how all this started some years ago, and it was just to try to bridge the gaps between the different stakeholders in the quantum ecosystem. So QURECA was born 1 year ago, a little bit more than 1 year ago, and QURECA means Quantum Resources and Careers. As you probably know, I got this fellowship from the Optical Society, and that was really the push when I said I want to bridge those gaps. Okay, go and do it. So what does it mean at the end, QURECA? What is the goal of QURECA? It's really to create a common language for everyone working in quantum. For the people who just want to understand all these news around the world, for companies to develop the businesses and grow the business, to also create a strategy, for everyone to be ready for what is coming, the quantum world, the quantum future, quantum technologies, because we need to create value, to create an impact, and at the end to create business. That's going to be the future of quantum technologies. So QURECA offers different kind of services. We work with quantum companies on really supporting them on growing the business. Where do we have to look at? Who could be the customers? So what are their needs, and try to support them in this direction. And this is critical because most of the people developing now the technology, we are talking about academics, scientists who suddenly realized that what they were doing for a lot of years, that fantastic research can be commercialized, and that's not an easy jump. That's why we try to support them in this growth. Then we also work with end users who is going to be using the technology at the end. If we think about all the different sectors in finance, in telecom, and pharma, what does it mean quantum technologies for them? Should they start building a strategy now? Should they wait? And strategy is something in long term. And you probably know that most of people, we don't think about long-term, because it's true. We just look at what is going to happen in very near term. Even politicians don't look in the long-term future of the country. So it's really hard to think about strategy. And this is critical in terms of emerging technologies such as quantum technologies. And then one of the big focus of QURECA is really about skills and training and resourcing. And that came because so many people were thinking, they were mentioning every time how difficult it was to find people with the right skills, how difficult it was to understand how the skills that they acquire, maybe they were not the right ones. They need to develop the skills to be part of the quantum workforce. So we try to focus on that. How are we doing that? Well, we are working on our quantum skills and competencies platform that we have in our website. So if you go to our website and then you register, you will see our platform. So the idea, how does this work? What we are doing is creating a training program that anyone, being a PhD student who wants to go into industry, somebody who wants to change their career after 30 years working in somewhere, anyone who wants to be trained and upskilled in quantum technologies, we acquire those skills, and then these people can be placed into a quantum company. This is really the idea about how this will work. This is our business model, but we also want to support companies who are actually recruiting at the moment. So as you can see, this is really training and recruiting. This is the whole way of focusing on skills, and what we want is really to build the quantum workforce. So at the end, we want to develop this new quantum workforce that we know is going to grow exponentially in the next years. So our unique selling proposition is a global network that has been built over the years, talking to a lot of people. And again, thanks all of you for being here. I've met you in one event or another. And also the expertise. We have people with expertise in business, in academia. We have very different kind of skills. And again, the importance of skills here. So what we do is we work with individuals who want to develop their quantum skills, and then we try to understand what they want to do with their careers and place them into this dream job. We work with companies to, as I mentioned before, business development, business intelligence, so develop the strategy, kind of professional services, but we also help them with training and, of course, with recruitment. So that's, I think, enough about QURECA, but just to give you a little bit more, because as you can see, what we are doing today is a little bit different. So just to complete the package, we provide on education. We are creating these online courses that we are creating at the moment, and we are really looking forward to start providing these courses. I think in the next month or so, you will have the first course ready. So you can already register your interest if you want to know more, and we will have specific online courses tailored for specific sectors. So we are going to have quantum computing for finance. We are going to have different quantum computing languages. We are going to have quantum technologies in like kind of different kind of introduction levels, and we are going to have courses in different languages, which is really important because, again, we are global. We also work on education through webinars and workshops. And today, as you can see, one of the things is really to educate ourselves what is happening globally in quantum communications and cybersecurity. Again, recruitment, we provide recruitment as a service, and we also organize career events. So if you are looking for a job in quantum in the near future, or if you're a company who is looking to recruit in the near future, let me know, because there will be a career event at the end of October. And it's going to be virtual, obviously, but it's going to be big. It's going to be, we hope it's going to be kind of the first of all these career events where we're trying to bring together people looking for jobs and companies looking for people. Also, we are creating tutorials in different conferences. We will have one at the IEEE Quantum Week in October to kind of upskill people. What is important? How can you tailor your CV if you are looking for a job in quantum? Of course, a lot of information. We are trying to put a lot of resources on the website, and if you have ideas, they are welcome. And we are trying to put more and more content. And community building. This is, again, one of the important things and what we are doing here today. We want to create communities in different end user sectors and in different technologies. We want to bring together people working, in this case, in quantum communications and cybersecurity, that they can just have a chat, that they have a discussion. What are the issues that they face? Probably the same, but it's always good to share your views, to kind of not just being in front of the computer, looking at some slides and hearing to someone talking, but just have this opportunity to discuss with each other. So I really hope that you enjoyed the discussions today. And of course, regional, we are going to create some communities around the world, and we will have the first quantum computing meeting in Latin America next year. So as you can see, we are really busy. Just one thing, there is this calendar if you register on the QURECA website, and then you will have your learning part, or you will see calendar for events. So you will have this calendar where you can download directly to your calendar, and you can look for, right now mostly it's virtual, but you can see different locations, different topics, and we try to be up to date with all what is happening in the quantum world. So that's me. Thank you so much again for being here. You know where to find me. Now I'm gonna give you a little bit more background of what is coming next after all these talks. So after the talks, we are going to have these roundtable discussions. There will be 3 different discussions. One focus on quantum technologies for the space sector, where Sonali is gonna be the moderator, and we will have someone for QURECA also helping Sonali if you have any questions, but you can always use the chat. In this case, you are on stage, so the chat will be the stage chat on your right-hand side in your computer. And every time you will have a different chat specifically for where you are, but there is also one for the whole event. So there is another session on QKD, QE or QKD and PQE. Yes, is post-quantum part of QKD, or is actually separated from QKD? This is a big topic, and Bruno is going to moderate this session. Then the third session is about the components, really. What are the technical parts that we need to have this cybersecurity infrastructure when we think about quantum technologies? And there, Ian and Colin are going to be the moderators. Once we finish all these talks in the first session, you will need to go to on the left-hand side of all the whole event. You will see these sessions. You click there, and you will have the 3 sessions, and you can join one. We will advise you to stay in just one session, because it will help to. I think the discussion will be more fluid if you are not just living like in the middle of the discussion. But you are free to move if you want. If you want to actively participate in the discussion, please join with video and audio. If you just want to kind of be there but not participate, just please turn off your audio and video. Any questions? Again, use the chat. So that will be between 2:30 and 3:30. I know that's UK time. There is people from all over the world here. So yeah, I guess good morning, good afternoon, good evening to all of you. The last part of the session today, starting at 3:30 UK time, it will be the speed networking. Again, on the left-hand side of your screen, you have this networking button. This will allow you to talk randomly with someone who is also on this networking part of the event. And you can talk for maximum 5 minutes. From 30 seconds to 5 minutes, you will have the chance to talk to this person. If you want to stop the conversation, you can, but you cannot be talking to this person for more than 5 minutes, because you will have a time in telling you that is over. If you want to connect to this person, there will be a button to say connect. And once you finish the event, you will see on your hopping panel all your connections. So you will see all the LinkedIn and email if the person put this on the profile. And I think that's all what I wanted to say today. Yeah, any questions so far before we continue with the talks? There are no questions in the chat. Okay. Good. So we are going to start then with Sonali Mohapatra from Craft Prospect. Sonali, if you can join me, yeah, the floor is yours. Thank you.
Thank you, Araceli. Thank you, everyone, for having me here. Just going to take a moment to share my screen. There we go. So good afternoon, everyone, and good morning and good evening to people from other parts of the world. I am Sonali Mahapatra. I am the Space Quantum Technologies developer at Craft Prospect. And today I will be giving you an overview of Craft Prospect and some of the work we do, especially in the area of quantum technologies and cybersecurity. Craft Prospect, as some of you might know, is a space engineering company based in Glasgow, and we focus on smart, secure space. We do this by understanding that there is a new growing problem in new space arenas. Space operations are costly and outdated. And in order to ensure that space operations are available to a larger number of people, and they're also available for the onboarding of new kinds of technology so that we can together progress to a new direction, we do this by delivering CubeSats. And we do this by making sure there are various parts of our business which focus on making sure we have technology on CubeSats. So our different parts of the business are the mission architecture part, the responsive operations part, which can otherwise be known as onboard autonomy, and the quantum cybersecurity aspect in which I am involved in. And together, all of this comes in quite naturally to ensure that we are moving forward, hands held, to ensure that the future is smart and secure. Um, I'll talk a little bit about why we want to onboard cybersecurity onto satellites and why we need encryption. Now, as all of you understand today's world is full of high value data. All of us use data in various different ways. We use our credit cards and banks. We use electronic medical records. We use various different satellite imagery data to ensure that we have prior warning about storms and weather systems, and so on and so forth. Now, with dealing with such a huge amount of data comes with its own responsibilities. We have to ensure that this data is protected. But with the advent of quantum computers and with the advent of quite a large number of quantum technologies, this encryption today, which uses public key cryptography systems, and in turn, they depend on mathematical complexity, it poses a threat to them. So we can take a leap forward and ask, can we use quantum in a different way? Can we use quantum to actually mitigate this threat? And this is where quantum key distribution comes in. As many of you might also be aware of, quantum key distribution is something that uses um, single photons, so quantum properties of atoms and single photons to send information from one place to another. So basically, here's a little infographic, a video of what quantum key distribution is. So you have Alice on the left and you have Bob on the right, which is very common quantum speak. So for our case, what we try to do is Alice will send single photons to Bob. Now, the different arrows in this infographic basically show that these information can be encoded in the various different polarization of the photon. So what we essentially do is we produce strings of zeros and ones, and we send it via a quantum channel to Bob. At the end of this whole process, Bob will be decrypting a secret key, which he can then use to discuss with Alice or have further secret information with Alice. Now, the problem is when there is an eavesdropper. With an eavesdropper, when you do quantum key distribution, one good aspect of this is since you're using quantum technologies and quantum uncertainty principle, there are various different theorems like the no cloning theorem, which ensure that if you have an eavesdropper, you would always be able to find out whether they have been listening in. So you take some parts of the secret key that you have, the raw key that you have distilled out after Alice sends you her photons, and then you do some error correction and you find out what is the threshold of this the error. And depending on the threshold, you can always tell when someone is listening in, even though it is a quantum computer. And in this sense, you become future proof towards any kind of hacking, for hacking efforts on your data. Now, the problem is we do already have quite a lot of quantum key distribution efforts, and some terrestrial networks of quantum key distribution already. There are quite a lot of commercial efforts which try to ensure these terrestrial networks are set up properly, and we can actually use quantum gate distribution to within a certain distance. Now, terrestrial networks actually have a limitation. We can only do quantum gate distribution through fibers and repeaters till 500 to 600 kilometers. Uh, if we want to do free space, well, like atmospheric quantum key distribution, then there is atmosphere on Earth, and it will also hinder sending photons above a particular amount of distance. So if somebody is in one continent and somebody else is in another continent and the distances are large in between them, what do? This is where satellites coming, and this is where quantum Crack Prospect is also having its first mission, known as ROCS, the Responsive Operation Key Services. So what we can do is actually we can erect two different ground stations in two of these continents. Two of these continents or two of these parties can basically have an agreement, and you can set a satellite up. In our case, ROCS is going to be a small satellite. It's actually a CubeSat, a size of a cereal box carton, and it will be having a quantum payload in its inside it. So ROCS is going to have so basically the satellite needs to open a channel to one ground station. It will share quantum. It will be a quantum channel in which it will send down photons and share quantum key distribution. The ground station will be able to distill a secret key. The satellite is also going to be opening another channel when it passes over the second ground station to share a secret key with the other ground station. In this way, the satellite acts as a relay between the two ground stations, which are separated by a large distance, and so it reduces the distance effectively. And it's much easier. Well, it's much easier in a sense than terrestrial QKD, because the photons have to travel quite a lot in free space where we do not have an atmosphere, so there won't be quite a lot of refraction, turbulence, and so on. Right. So basically, when I was saying that ROCS is going to be a CubeSat, this is how CubeSats are measured. So there is the unit of a CubeSat is 1U, and ROCS is going to be a 6U CubeSat. And I have put a little picture of a bread slice pack to show you kind of the scaling over there. The satellite bus, the CubeSat bus, the outside frame basically looks like the one we have on the left. And so that is our ROCS mission. Now, basically, the ROCS mission will try to do this to be a part of a future cybersecurity toolbox. We'll do quantum key distribution to send secure keys, which will then further go through a huge array of complicated quantum safe assurance, secure storage, doing post-processing and error correction, and a key management system to interface with various different internets, to interface with any kind of customer that we have. So part of doing that is making sure we have the right products to ensure that we can actually deliver what we are promising. So we're promising you safe, secure space, and we want to deliver quantum key distribution and various other products to come in a total package to ensure that this actually happens. Now, ROCS will also have our first product, which is a forward-looking imager. This is an imager which looks ahead when the satellite is moving in its orbit. It wants to ensure that we actually have a pass we actually have a fruitful pass. So the forward-looking imager will look ahead. It will ensure that there are no clouds on top of the ground station, because clouds can hinder quantum key distribution links between the satellite and the ground station. So the fly is going to look forward. If there is no cloud, it will ensure that, okay, quantum key distribution can go on. If there is cloud cover on top of the ground station we wanted to share a key with, we want to ensure it will autonomously take this to decision on board and ensure that we can point towards another ground station and share keys with them instead of losing the whole pass. So basically, it enables onboard decision making. Our second product is going to be the JADE, the Joint Alignment Diode and Emitter. It will have a bespoke quantum source on board with an APT to monitor the power output and an alignment laser to create a complete source package. Now, if you have needs of quantum sources for your own QKD networks, for your own QKD systems, we would be happy to send you over data sheets, because we're quite excited about announcing JADE now. We also have quite a lot of other products which we are hoping to announce and unbox, and hence the unopened gift box over there. To show you a little bit about how things look like, we work quite closely with our academic partners. I work quite a lot with the University of Strathclyde. I know that Dr. Daniel Oye is in the audience. I work quite a lot together with him. We also work with the University of Bristol quite closely, and we worked to take the test bed systems and miniaturize them heavily in order to make them space ready. All of this will basically go through space qualifications, vibration and stress testing, and end-to-end security testing to ensure that everything is secure. Not only the QKD part, but also every single classical channel, classical components, electrical and embedded systems surrounding it, as well as space and environmental testing to ensure that this works quite well in the space environment. On the left-hand side, you can see the little box, which is basically Jade is going to be a little version of that, and this is the whole box, we call it the Opal, which is our optical payload, which will go on top of the rocks. On the right, you can see our team, along with the University of Bristol and the Strathclyde, presenting our work at the Quantum Technology Showcase last November. And there you have the OGS, the mobile optical ground station produced by the University of Bristol on the right, as you can see. This is all I want to present now. If you wanted more information from us, please go on our website, www.craftprospect.com, and you will find a wide variety of portfolios for our past and present missions, as well as future missions. You will also find a white paper on the ROCKS mission, which is on the publications tab. We also have a quite thriving blog where we try to put in everything that we work on and our thoughts on them, so that because we feel quite passionately about outreach to the outside community, as well as QURECA was talking about, as Arathali was talking about. So thank you, everyone. If you have any questions, I'll be around for the discussions and chat.
Thanks, Sonali. I cannot see any question on the chat so far, so I guess we just continue. Next will be Sinisha Patkovic, and he will introduce Isara. Thanks.
Thank you. Can you see me okay?
Yeah.
Okay, very good. So I'm just going to run through a few slides quickly. So Isara is a Canadian company. We're based in Waterloo, Ontario, and Waterloo, Ontario is quite famous for research and universities. So in this little space of a few square kilometers or miles, you have the most famous or the largest theoretical physics institute in the world called the Perimeter Institute. Very, very good business schools, Institute for Quantum Computing, Quantum Valley Ideas Lab, so some sort of I would say, incubator for quantum ideas, many labs, and then you have a venture that focuses on quantum called Quantum Valley Investments, and this is where Isara is located as well. So 1.6 billion in these technologies. So Isara was founded in 2015. We've received quite a few investments so far. We have about 35 employees and a few consultants. And we have quite a few partners that we've achieved over time. They range from OEMs, manufacturers of equipment, systems, certificate authorities, PKI companies, digital signature type solutions, and common access cards for physical access and so forth. In terms of our products, we have built a few products so far. So one of them is Radiate Toolkit. We license it to developers and OEMs, and this toolkit includes quantum safe algorithms and an easy way to implement them in many environments. Isara Catalyst Agile Technology. So Catalyst is a technology that we have built and standardized now with ITU. It's an extension to X509 standard, which allows for hybrid certificates and hybrid use where both classical and quantum safe algorithm can be present in X509 and consumed by PKI, and we offer professional services. So why we're in this business? So as you know, the quantum computer is not new, but it's expected that over the next 10 to 20 years, it's going to be sufficiently strong to run Shor's algorithm. And Shor's algorithm is proven to be able to defeat the mathematics behind classical asymmetric or public key cryptography. So we're definitely on that trajectory. Public key cryptography is also not new. It's from the 70s. RSA is the oldest standard we still use. Many have migrated to elliptic curves, which was introduced in '85. However, with quantum computer looming, these are not sufficiently strong, regardless of how much we increase the key length. So NIST is standardizing this right now, and we expect over the next 2 to 4 years that there's going to be a few of these algorithms that are going to be new public key algorithms. However, there are also algorithms such as hash-based signatures, stateful hash-based signatures that can be used today already, and they are quantum safe, which is important to note. So what does Shor algorithm do to cryptography? Well, it completely defeats public key, while Grover's algorithm, which is another type of square root attack, it decreases the strength of symmetric cryptography by half. So we can increase the key length and still be okay. In terms of public key cryptography, there's nothing that can be done. We have to completely replace the math and the schemes. Cryptography is everywhere, as you know. It's all the way from hardware to the application. It's used in layers, and it's we've assumed it's there. Most people never think of it, but soon enough, everybody will need to migrate, and it's going to be a very interesting time for the industry. There's two types to protect against quantum computer. One is physics, which we heard in a previous presentation, quantum key distribution, which doesn't address authentication, a few other areas, but it offers excellent properties in others. And then there is software, which is public key cryptography and software, which is what Isara does. What type of problems we're looking to solve right now for our customers? So these are authenticated software over-the-air updates in the industry. These are important because the root of trust is based on public key crypto, and it cannot be fixed in software, and it has to be replaced with a quantum safe crypto. And these are expensive problems to have. Identity management and migrations, these are very complex problems where there's PKI involved, and it's very hard to migrate from one standard to the other. And so we're helping customers prepare to migration to quantum safe. Access and authentication, so these two play with each other. So these are common access cards that use digital certificates, and they interact with PKIs. And then future-proof communications. This is any communication that needs to be secret for more than 10 years is already under risk, and this attack is called harvest and decrypt. So you steal in data now, and then you decrypt it once you have a quantum computer. So why is that important if quantum computer is not going to be around for next 10 or 20 years or even 30 years? Well, it's because there are many complex systems. So if we take a vehicle or a car, for example, which is something in the middle of the road in terms of complexity, or a life, not just complexity, but the life cycle. Jet engines, for instance, have three times longer life cycle than vehicles. So if we take a vehicle, it takes 6 to 8 years to develop and productize a vehicle, meaning that if you miss putting in the architecture that supports quantum safe keys, first or second year, you lose this cycle, and you're going with your production of a vehicle that's typically being supported for 11.5 years. So this together is almost 20 years. It's roughly 18 to 19 years of a cycle for a vehicle, meaning that it's very likely that quantum computer is going to be operational during that life cycle. What does that mean in terms of security? Well, an attacker with a quantum computer that can run Shor's algorithm will be able to reverse engineer digital signature just by having access to a public key. Public keys burn into all the hardware, all the phones we have. It's a manufacturer public key, and it's used to verify digital signature on the OS. So for these vehicles, an attacker will be able to load software, and hardware will trust that software because the digital identity, digital signature has been forged. And in order to fix this problem, you have to replace hardware. You cannot do any software patching. This is why we see, different industries moving at different speeds, and some of these long-lived devices, as you can see on the left, are already working on this. So these are our customers. We're already working with a number of these customers. And then complex software deployments are next in line. So complex cloud deployments, complex PKIs are next. And then the last one that can afford to wait maybe 1 or 2 years around NIST will be simple software type implementations, inexpensive phones, and similar types of quick life cycle and quick development cycle type products that will be essentially incorporating quantum safe crypto back then. These are the typical environments where we operate as a company, the customers we serve in aviation, so chipset manufacturers that need to incorporate different capabilities that are quantum safe. Military, definitely a lot of PKI and common access cards, as you can see on the right. Secure hardware devices, hardware modules, HSMs. We've done quite a few of those. They cut certificates and they secure keys inside of them. Most financial institutions have them. CAs, we have licensed number of CAs, and we've done a number of projects with car manufacturers as well. Thank you very much. This was a short introduction to Isara and our public key or post-quantum crypto business. We also do quite a lot on the agility front, because you cannot migrate your cryptography if you do not know where it is and what exactly you're migrating. So we're putting a lot of effort into enterprise-grade tools for discovering and providing visibility into cryptography as well, which is another range of products which I didn't include in my presentation here. I'm going to stop here and allow for any questions.
Thank you very much, Sinisha. Other questions? We are still waiting for our speaker, so please put any question on the chat. And Sonali and Sinisha are still here. Okay. So I see a question just saying, do you think that there is a race between the different countries being the first one having the first QKD network ready? So if you could just maybe Sonali, what do you think? You're muted, Sonali.
Yeah, definitely there is a race between countries to have quantum key distribution networks ready, but I think there's also quite a lot of global collaboration right now going on with various different bilateral collaborations like the UK, Singapore one, there's UK, Canada ones, and hopefully together we'll all go forward.
Sinisha, your thoughts?
There's all sorts of races currently. There's race in quantum, just in general in quantum, because it's a great strategic weapon or a tool that will equalize many countries after the Second World War, where we saw US being super advanced compared to everybody else in computing power. So many other countries see quantum computing in general as a tool to get on an even heel, to be on the same level as US and other European countries. So there's huge amount of effort happening across quantum everything. That includes quantum security, and that includes QKD, as well as the area we work in, which is post-quantum cryptography. So the race is on, absolutely 100%.
You're muted, Araceli.
Thank you. We are just waiting for Alexei to join us on the backstage. Oh, we have another question. So from Dino Sola Nikolic. Hi, Zanisha. How do you see the QRNG market in the near future, especially the high speed over 1 gigabps solutions?
Question is more for Sonali. We don't play in QKD market, which is a very specific market. They have very sort of narrow, specific focus and customers typically in telecom right now and government. We serve the market around QKD, which allows for authentication and other soft digital signatures and other software services that QKD cannot provide, so are served by post-quantum cryptography. So I'll let Sonali comment on the question.
Yeah, thanks, Anisha. I can take that one. It is very interesting a question. Definitely, as Anisha pointed out, QRNG is a very key aspect of making sure we have a secure QKD system. The important part for a QRNG for us would be to make sure that the speeds of a QRNG are basically up to date to what the speed of our sources are. Currently, in the QRNG market, I think there are quite a few players out there, but I haven't seen QRNGs which have speed, which can be actually used in a commercial QKD system without having a buffer in between. So I think that's another quantum race, like the first question pointed out. There are also QRNGs which are currently in today's market. Like I think Cambridge Quantum Computing just unveiled their QRNG, which you can use with IBM's quantum computer. So you basically go online and use their QRNGs, use like their Bell states which they produce to use the entanglement-based QRNGs. But for us in the space sector, we are really interested in looking at QRNGs which are small, QRNGs which are extremely fast as well, and which would be space hardy. And I think there is definitely a dearth in the market right now. There is a gap in the market which can be filled in the coming years, especially related to the speed.
There's another question I think for you, Sonali. What is the maximum key rate we can achieve with satellite QKD? Can you comment on the quantum error rate range by satellite QKD?
So for the ROCKS mission particularly, we are looking at 600 to 700 BPS, I think. When we are going over, so there are various different satellite classes we can look at, and I think satellite quantum key distribution can provide pretty good rates of quantum key distribution as compared with terrestrial quantum key distribution. The big thing here is understanding atmospheric losses and understanding how we can ensure that we model these things properly. We also ensure that our GPS is connected enough to ensure we are find out where we are in relation to our ground station at this particular point. ROCKS particularly will do nighttime QKD to ensure that a lot of background light is reduced. There are a lot of groups around the world who are also involved in modeling of daylight QKD right now. So I think the rates over there are quite low as compared to nighttime QKD, but there are quite a lot of different things you can do in the analysis side to ensure the rates are up. Sorry, what was the second part of the question?
The quantum error rate range by satellite QKD.
Right. So I think looking at security proofs, we can tolerate a quantum bit error rate of 11%, but that does not mean that if you are around 10% or 9%, that you would be able to have a usable key rate. In order to have a usable key rate, you might want to get your quantum bit error rate as low as less than 5%, for example.
Sonali, we have another question from Paolo Bianco from Airbus. Again for you, Sonali. The integration, communication, handshaking between different QKD systems being designed and built today?
I guess I'm a little confused by what are the different aspects that you're referring to, but I'll take a stab.
Maybe we can leave this for the discussion in your roundtable later. I think this is maybe one of the best questions to start with. And there's another question, but I think Alex
able to talk to Sinisha and Alexei as well, and talk about the different parts that they're working on, how they all integrate together.
So okay, I'm really happy to see that Alec finally joined us. So Alec, I think the floor is going to be yours right now. So if Sinisha and Sonali, if you can turn off your video. Alexei Fedorov is going to present the quantum technologies landscape in Russia, and he's going to present also a little bit about what Qrate is doing. So thank you.
Yes, thank you very much. Could you please give me a permission to share screen? Because I don't have it now.
You should be able to.
And by the way, hey from Russia.
You should be able to do it directly. So you have the video, audio, and then you have the share screen.
Yes, it's crossed by red line, unfortunately. So I don't see the opportunity how to do that. Probably it's something in the, but everything okay from my side, from the restriction point of view. But let me then, start from the just introductory words, because I'm a little bit late because of the ongoing very large forum in Russia, which is devoted to quantum technologies, and quantum technologies in Russia get a lot of attention because of writing big roadmaps on the development of quantum technologies, and they are now, formulated as 5-year research goals, R&D goals basically, so goals in research and also in development of quantum communications, quantum computing, and quantum sensing systems. And here, yes, I'm now able to present the screen. Yes, so probably now you can see it.
Yeah, perfect.
Could you please confirm that my screen is seen? Yes, thank you very much. And I would like to present here the family of our project, which are work intensively on the landscape of quantum technologies in Russia. That's 3 projects, which is devoted to quantum communications, QSpace, which also about quantum communications, but on the fiber, on the free optics and satellite side, and also QURECA, where we work with post-quantum solutions. And we believe that integrations of all of this technology in one unique ecosystems will help us really to convince users to start use quantum technologies in the cybersecurity goals and the information protection goals. So I think that it was already mentioned many times that the race for quantum supremacy is intensive, and many companies and governments invest a lot on the development of quantum technologies. It's now there is a big progress in from the side of commercial companies like Google and Intel and IBM, Microsoft, also Amazon joined this quantum race in order to build a quantum computer, and having a lot of good applications like quantum chemistry and optimizations quantum computer is dangerous for cryptography. We all know that. And that forces industry leaders to consider opportunities to migrate on quantum or post-quantum cryptography for data protection. So there are a lot of interesting projects there. So we also hear from the side of quantum and post-quantum cryptography trying to work with end customers. I will comment on this a little bit later. So again, we believe that ecosystems of quantum technology can be built on the top of whole technological opportunities that they have for making quantum communications secure. So first is fiber communication systems, which is now well deployed, and there are a lot of interesting projects in the world and in Russia on the development of fiber-based quantum communication systems. So they require the infrastructure of fiber cables, but this infrastructure does exist and can be efficiently used. Such a technology has a lot of benefits. It can provide security on the level of quantum mechanics. But at the same time, up to now, there are some restrictions, for example, in the length of which we can distribute secure keys. And here we can be saved by using free space or satellite-based communication links. And we have project QSpace, which exactly works on this goal. And then sometimes it's very complicated to integrate quantum cryptography now, even if the application already requires the security because of already mentioned attack of harvesting now, decryption later. And that is why we accomplish our ecosystem by software project working in the field of post-quantum cryptography. And our work not only from research side and development, we also work on support, education, and consulting. For example, in Qrate, we, in addition to industrial QPD system, have a modular QPD setup for education purposes. So speaking on the technological landscape, different levels in information security requires different levels of protections, and various technologies are better or worse suited for solving these problems. For example, on the user and application level, we believe that post-quantum cryptography is the best solution, at least up to now. But on the infrastructure and data centers level, quantum cryptography is already can be applied. And again, quantum computing is a big threat, and especially because already now we generate a lot of this data, which are critical from the viewpoint of attack, store now and decrypt later. That is why I think that it's the right moment to start to implement such systems. I will skip probably this general information, but again, let me just point it out carefully that the main advantage of quantum cryptography is the ability to have information theoretic security. So in sense, security which is not based on any assumptions about limitations of eavesdropper. Security of quantum communications is based on the laws of quantum mechanics. And how we see its applications now is generations of keys which can be used for standard data encryption systems which are now existent, well deployed. That is why a lot of our interest at the interfaces of quantum and classical devices and making applications for end users. So we believe strongly that an important market here is important a market of end users applications based on this quantum secure infrastructure. So speaking in terms of products from Qrate side, that's industrial data communication systems. Already mentioned by myself, academic device, which helps us to also work on for educational purposes. We also have two sub-products inside quantum key distribution system, which can be interested by itself. That's quantum number generator, which can be used for industrial purposes. And we have this device on very high level of technological readiness. And also this our own single photon detector. And all of these devices have original technologies that we are developing. And that's our technical parameters. As you can see, we are best in Russia, and we are comparable with devices that are accessible in the world. And we believe that we can go even further. And as I mentioned, we strongly believe that this market of quantum solutions is driven by applications. That is why one of our main application was creating of quantum secure blockchains and distributed ledgers based on quantum cryptography. So that helps us to explain end users what kind of applications they can secure via this infrastructure. And that's about our pilot projects, which are very important for creation of this market. So we, for the first time, demonstrated this in Russia with Gazprom Bank, and then with Sberbank on the real information lines by building protected VPN tunnels. We also conducted a lot of demonstrations together with Rostelecom, which is the largest Russian telecom operator. And in the field of post-quantum cryptography, on the top of the separate project, which I will describe now, we have a deep integration between quantum and post-quantum cryptography inside our products. And we see increasing interest in Russia to this technology and also in the world, so we will be happy to explore our opportunities in collaboration with international partners. About QSpace, already now we have some prototypes of systems that allows us to transmit secure keys in free space communication channel between trusted users. And we will explore this technology further for ground Earth and satellite-based applications. And here we also would like to collaborate with international partners. Again, speaking in terms of applications, we see a lot of potential from QKD, not only in traditional markets, like data communications between data centers, but also in new in emerging markets, like markets of autonomous cars, which require high degree of control for example, for software updates. And that's one of the new markets where information security needs life safely. And we believe that it's very important on the very early stages of this market, incorporate best solutions. And the best solutions here is, of course, quantum secured communications. And that's how we can see the future of the further world of transportation systems that can be built on the top of quantum communications. And here we have connections between data centers, between cars, and between autonomous cars, which are connected via fiber optics and free space quantum communications. That's one of the futuristic picture of further applications. That's about our proposals. So we are aimed on the creating pilot and R&D projects, and also by providing educational services without academic device, which is flexible and can be used either for education or for research purposes. So here we are very interested in collaboration with university and research centers. Also, as I mentioned, we are very interested in cooperation between post-quantum and quantum cryptography. So we see on these technologies not like competing solutions, but on synergy between them. And we already deploy algorithmic solutions on the basis of post-quantum cryptography in various applications like mobile applications and IoT. And here we try to explore the main prospects of this technology, which is low cost, easy to use, and easy to integrate to potential customers. On the QURECA level, which is a company on development of post-quantum solutions, we already have SDK, which is tested by several partners in Russia, and it can be used for creating new technologies based on our solutions. So we basically provide core library of quantum solutions that can be integrated by end users, and also end users applications like QTunnel. So that's our proposals on post-quantum cryptography. We again are interested in end user integration in cooperation, because here integration takes really in standard cases just few days in order for business just to try and understand what this technology is. We are happy to provide research as a service and happy to provide educational and consulting services. We believe that our ecosystem, which consists of whole solutions providing quantum security based on quantum, fiber optics, and free space communications, and post-quantum cryptography, will help our partners and potential customers to enjoy all the opportunities that quantum technology gives for the information technology of the future. And here we're interested in R&D projects in partnership with our colleagues, and of course in realization of R&D projects and investments. So thank you very much for your attention. I would be happy to answer on the question that you have. Thank you.
Thank you very much, Alexei. Are there any questions for Alexei before we wrap up and we go to the roundtables? I don't see any specific questions. There were 2 questions before, but I think we just leave these for the discussions. So again, thank you very much for all your talks. It has been really interesting. We have seen that it's very, very different in the market, as we see from the different applications. Also how we are working on this really globally, which is very, very interesting. And that's why we are here as a community and see how we can collaborate and work together. Okay, so again, we are going to split now in 3 different sessions. I'm gonna share again the slide, just that I want to make sure that you know what you have to do now. So you should be able to see now. There are 3 different sessions. You can choose which session you want to join, and you are free to move between sessions if you want. But we really prefer if you can stay in the session that you choose, because it will help the discussion. Just need to go from stage to the sessions, and this will run for an hour. And then we will start the networking session at 3:30 UK time. So I hope that you enjoyed the discussions. Again, it was a pleasure knowing from all your work. So again, thanks the speakers today, and enjoy the discussions. Talk to you soon. Bye.